This video will discuss Chapter 10.3, Operations with Radical Expressions. So we're going to start by taking a look at something like this. Okay, and so the idea is that now I am adding or subtracting radical expressions. So I'm essentially looking for like terms. And if you think of this radical expression as almost like the term or the variable, I can combine the outside numbers while I leave the inside number the same. And I'm actually going to show you why this trick works in just a second, but essentially I'm going to add 5 plus 7, which is 12, and then 12 minus 6 is 6, and so my final answer is going to end up being 6 times the square root of 2. And a lot of people want to know, why is it that I'm allowed to do that? Okay, and so I'm going to erase this. We'll come back to that in a second. And so if you want to see the magic behind this, because it's really not that magical, it's essentially the distributive property, right? And so I'm going to say, well, they each have a square root of 2 in common. So I'm going to divide each of them by the square root of 2. If I divide this by the square root of 2, and I divide this by the square root of 2, and I divide this by the square root of 2, the square root of 2 part is going to cancel out. I'm going to be left with 5 plus 7 minus 6. Right? 5 plus 7 minus 6, so this is the square root of 2 is on the outside, and now I've got times 12. And so remember, the commutative property tells me I can multiply in any order I want. I'm sorry, I didn't write 12. It should be a 6. Forgot to subtract the 6. The commutative property tells me I can multiply in any order that I want, and so I'm going to move the 6 into the front, and so this is 6 times the square root of 2. Okay, that's the magic behind it. You don't necessarily have to show me this work every time. Really what I'm going to do is as long as they have the same radical, we can add the outside or subtract the outside number. So 5 plus 7 is 12, 12 minus 6 is 6, and that's what's going to get me to there. So really this is the part that I would definitely need to be able to see. All right, well, what happens when we kind of mix them up? So what happens when they don't necessarily have the same radical? So what I'm going to do here is I'm going to use the commutative property. I'm going to move things around so that I can get the 10 to the square root of 7 plus 4 times the square root of 7, because those have like terms, plus 5 times the square root of 11 minus 6 times the square root of 11. And so you'll notice that I essentially switched these two, right? All I did was switch the order. And the commutative property allows me to do that. And then what I'm going to do is use the associative property. I'm going to group these two together. And since these both have a square root of 7, I can go 10 plus 4. So this is 14 times the square root of 7. And then I'm going to take these two and put these two together. And that's 5 minus 6. So that's minus 1. So minus the square root of 11. Now you could write a 1 here, but you don't necessarily have to. And so my final answer, because I can't then, and what happens, a lot of people then try to put these two together and get something like negative 4, but you can't subtract when they're not like. So my final answer is 14 times the square root of 7 minus the square root of 11, and this would be the final answer. Right? And so essentially I'm just combining like terms. It's the same concept as combining like terms. All right, well now what happens when none of them are like terms? Okay, and so this is where you want to take a look at something like this. Aren't you glad you wrote this in your notes previously? So what I'm going to start looking for are perfect squares. Right? So I'm looking at this first one, which is 18, and I know this is the same as the square root of 9 times the square root of 2, and so this is a 3. So this becomes 3 times the square root of 2. And so I know that 3 times the square root of 2, and so now this is the same as the square root of 18, and I have this 2 on the outside. So this is actually going to become 6 square root of 2, right? So this square root of 18 is the same as the square root of 9 times the square root of 2, which is 9 is 3. Square root of 9 is 3, so this is 3 times the square root of 2. So this is 3 times the square root of 2, and then I have to multiply it by the 2 that's still on the outside. And so it's the 2 times 3 gets me this, and the square root of 2 is still there. All right, over here, this has a square root of 16, and it would be the highest perfect square. So this is square root of 16 times the square root of 2. Right, and so this is going to be 4 times the square root of 2. But don't forget about this 2 that's on the outside. So this is 2 times 4, so this is going to be plus, because this plus is coming down. It's going to be plus 8 times the square root of 2. And over here, this one actually has that bottom one, the square root of 36. So this is the square root of 36 times the square root of 2. Square root of 36 is the same as 6 times the square root of 2. Since there's nothing on the outside, there's a 1 on the outside, I don't have to worry about that. This plus is coming down, so this is 6 square root of 2. So as I put these together now, they all have a square root of 2, so now they do actually have something in common. So I'm going to go 6 plus 8 plus 6. This ends up being 20 times the square root of 2. So as I simplify all of this into 20 times the square root of 2. Right, so the idea is that, similar to what we were working on in the previous lesson, we're breaking each of these down, trying to simplify each of these before we can actually start worrying about combining or doing some type of operation with radicals. Okay, and then the final type of problem is a multiplication problem. 3 times the square root of 2 times 2 times the square root of 6. And there are a couple of different ways to solve this. One way to solve this would be to multiply the outside numbers and then multiply the inside numbers. And so that would be 3 times 2, which is 6, times the square root of 2 times 6, which is 12. Now your problem is that at this point I still have to simplify this 12, and so this becomes 6 times the square root of 4 times the square root of 3, right? Because there is actually a perfect square inside of 12, and so I'm going to break the square root of 12 into these two. And this becomes, the 6 is still there, this becomes a 2 times the square root of 3. Right? And then I'm going to multiply 6 times 2, and I got 12 times square root of 3. That would be one way that you could solve it. A second way, and I'm not going to tell you which way I think is better, because both of them would work, would be to break each of these down. So 3 times the square root of 2 times 2 times, I'm going to break the 6 into the square root of 2 times the square root of 3. Right, and so here's my 3 times 2, so that's this part, or 3 times square root of 2, sorry, and then these 3 are 2 times, and then this is my square root of 6. Okay, so now I'm going to combine these two, so I'm going to end up with 3 times 2, I'm going to move this to here, and this to here, or I guess combine these two, right, so 2 times 2, this becomes the square root of 4, because I want to create a perfect square, times the square root of 3. This is going to become a 2, so I got 3 times 2 times 2 times the square root of 3. 3 times 2 times 2, so 3 times 2 is 6, times 2 more is 12 times the square root of 3. So you'll notice that either way is going to get you to the same answer. It really doesn't necessarily matter which one you do. In fact, sometimes it may be easier to solve it this way if these numbers are going to create a really large number inside. If they're not, and it's only going to create a number similar that's around this size, it may make more sense to multiply the outsides and multiply the insides. Right? Both methods work. It really kind of is a matter of preference, what seems to work best at that time. All right, that's all we got for you today on operations with radical expressions. Thanks very much for watching the video. Don't forget to do the problems at the bottom of the page. I'll see you in class.